So I'm going to go over this motion vector technique that I use to control this particle system. The basic idea is to get the current position of the head and like a previous position, and then draw a line. And that gives you an angle that you can use to control particles and stuff. So this project, you can see the lag here. Too many particles. I'm gonna totally just close this out and start from scratch. I'm keeping this open just as like reference because there's a lot of stuff going on in there. It's not crazy though. It's all pretty simple concepts. I'm just going to get rid of these. I guess step one is to get a face tracker. It comes with a face mesh, but we don't actually need to show anything on the face, so we're going to delete that. And you can just drag that into the patch editor and it'll give you 3D position, scale, rotation, all that good stuff. So we're also going to need particle system. So I'm going to put it in the face tracker so it like follows my face. And you can see that is working. So I'm going to try to zero out all of this like default behavior, just to give us an idea of like what's actually going on. Like for one, I want a ring. It's hard to tell what's going on, so zero out the speed just so I can tell where all the particles are being born. So quite obviously that's not what I want. I want the ring to cover, you know, a good portion of my face. So it's hard to tell, but the ring is actually flat right now. So I'm just going to go ahead and rotate 90. I think that's the right number. 90 on the x-axis. So that looks right. Give it a material, just so it's not the default. And just gonna make it flat. Maybe knock down the opacity. Add, why not? Okay, so it looks like it still has some tilt. Yeah, tilt. I'm gonna zero that out. And then we'll say like 2 seconds. Okay, so that's pretty cool. So to get the actual motion vector, there's a little trick. First, I'm going to need to unpack the position of the face. So this is our current position. So we need a way to get the previous position, and we're going to do that with expo smoothing. So you can see in the docs, it returns a smooth signal. So basically, it's tweening its current position to like a target. So the target is the current position of our face. So it's always going to be kind of behind. And then we can get the difference of those 2 points and tell like which direction the face is traveling. So what do we need? Exponential smoothing is great, but it only does scalar values. It's kind of annoying. So you gotta break that out. And you can mess with the damping. I found that 200 is fine. But if you want it to be like more, I guess, accurate or like tighter, more responsive, I don't know. You can lower that number. And then I'm just gonna go and pack that right back in to vector 3. and then subtract from the current position. And what does that give us? That just gives us the vector. Currently we're not doing anything with it, but it's the vector of the face motion. So to get like an actual angle from that, we're going to pipe it into, I forget actually. I think it's just going straight into arctan. I gotta pull up the reference. Okay, so we gotta unpack this. It's a lot of packing and unpacking. And in this demo, I'm just using X and Y. So it's like 2D motion for the particle system, but you could also use this Z value for something. Maybe that's not where it would come from. I don't totally know. I think I played around with it and I was like, it's fine without the depth. Like the particles are already tied to my face, so like their initial spawn position is going to be accurate in space anyway. I didn't find the Z depth added a whole lot to it, so I left it out. Arctangent. What does that give us? It gives us an angle, but this angle is going to be in radians, which is not what we need, because where is it? Oh, the spray angle of the particle emitter accepts values in degrees, so we just have to do some simple math to convert that. So the formula to convert from radians to degrees is multiplying the radians by 180 divided by pi, which is 3.14 approximately. So this is a pretty cool feature. You can just type in like a math expression and then it'll automatically evaluate. So that's pretty cool. So now we have our degrees and we can, it gets a little confusing at this point because we had to rotate the initial like particle emitter surface like 90 degrees that way. So like everything gets translated or rotated. So this was the y-axis and now you flip it. So y-axis is now where z was. That caused me a lot of confusion. But basically I just like played around with numbers and like it worked. So we're just gonna pipe this angle into pack. So this angle is going to be the y angle because the rotation is going to be around this axis, which, yeah, we flipped it, so that's y. So we're rotating around y. And then I think we have to do some more rotation up there, but we'll just pipe this into the spray angle. And then, of course, we need to give it some speed so it actually moves. Yeah, so I mean, it's doing something. You can see that the particles are moving in z space, and we want them to move on x and y. So we definitely have to rotate. So I think if we rotate the z-axis, it's a little hard to tell. And it's still moving in z space. Oh, I think in here I need a 90. And then maybe remove this one. Okay, so up and down are reversed, and then left and right are reversed. I think this ended up being different. Like, I don't think I need this. Maybe I'll just try rotating 180. Nope. Okay, up and down is correct. So it seems like I need to rotate 180 on the z-axis. I mean, so I like made this effect and then I tried remaking it, and somehow the rotational values like aren't matching up. So left and right. I mean, I think it's good to see this kind of like process. Like everybody does it differently. Like everybody solves problems in a different way. And a lot of my experience in Spark is just like tweaking numbers for many hours. So if we need to rotate, that would be on the z-axis because it was rotated. So maybe try 270. And the vertical's wrong now. Okay, that was correct. So left and right are correct, and then verticals are flipped. So I think X would have to be flipped 182. No. All right, going back to 0. So I think rotating 90 on X was a good call. Yeah, because that's the, okay. I mean, eventually something is going to work. I might just give up on that. It's going to work in the example files, of course. So there's that. You can just use that as reference. Even though it wasn't working exactly for me, maybe you can just try this, adding -90 to the y. Oh, what do you know? It does work. Okay, so cool. I guess going into more details on like how to make it feel like a natural thing. There's this little tab called force. So if you just want to apply gravity, that would be pretty simple. So it kind of looks, yeah, it's on. It's not very strong, so we can bump it up. Let's do like 0.1. So it's pretty cool, like feeling fairly natural. You can kind of throw the particles with your head movement. So another thing, this tripped me up for a while. even though we have the particle system space set to world, for some reason Spark doesn't add the capability you need. It doesn't add device motion. So like even when this works in the editor, so when you move around the camera or the device in the editor, you can see that it will follow the movement of the device. But when you go to test it on device, that won't happen. So if you go to project properties, capabilities, it won't even let you add device motion manually. So it says this capability is automatically added or updated when modules are used in a script, device motion, patches are added, device motion, model is used, object is placed in world space. So, I mean, we want our emitter parented to the face tracker, so that's not in world space. That's in local space. So this is what I did. Modules are used in a script. I just pulled in device motion in the script. But I think you can just add a device motion patch, which, yeah. So I think as long as you add this guy, it'll be fine. And like the world spaceness will work on your device. If not, you can try to require the device motion module in a script. That's what worked for me. So there's that. So I guess other stuff that I did in that script were in regards to like birth rate. So you can use, if we take the length, that's just like the absolute, or length and absolute is it's the total length of the motion vector. So that will give you like a strength value. So if I move like pretty quickly, we can do something with that. And it felt pretty natural to have it drive birth rate, just because if you're like shaking harder, it's gonna like shake more particles off of your face. So we can try that out real quick. So we need length. And then this, I think this is just like a subtraction from 0 or something. I don't know. But we don't care like what direction it's going. We just need to know like how strongly it's moving. So we're gonna use absolute because we don't want negative birth rate. I don't even know what that would do. And then where's birth rate? Lifespan, birth rate. Why is it expecting vector 2? Oh, because, yeah, that's weird. I think that's a bug. Maybe, hopefully this will work. So I'm gonna add a multiply to this because we're gonna need to increase this value. We're gonna pack in vector 2, I guess. Seems like that's what it wants. No. Okay, it just wants a scalar. And that works for some reason. I think that just this type is wrong for some reason. So you can see like not much is happening because this length value is like not very big. So we're going to multiply that by like, maybe that's too much. Maybe like 50. So it looks like oh, because I'm pulling it from the wrong thing. So this needs to go from there. It's sort of working. Oh, okay. So yeah, because we subtracted those two, the value is like pretty small now. Because it takes the difference like each frame. So the actual size of the vector is like pretty tiny. So we can just multiply that and get something more usable. So when I'm totally still, it'll pop out a few, and then when I move, there will be a lot more. What else? I mean, you can use this angle to maybe control like a tilt or spin. You could use the same technique to get like angular velocity of the face and maybe do something with that, like what is it called? Yeah, spin. Control spin on the particles like that. I think there was more stuff I was going to go over. Oh, we can do this real quick too, this speed. Pipe that into just a different multiply, because we're going to need very different value than birth rate. Where's speed? Speed. So you could also use, like we're already setting the angle here, but maybe you could use, you do some more trig stuff and like set the actual physics of each particle. Maybe that would be cool. I don't know. So what do we get for speed? It's going to be pretty low. Maybe try multiply by 10. Maybe something more like 3. So you can see like the faster I move my head, the more apparent like momentum gets transferred to the particle. I think that really helps a lot in making it feel like a natural like thing that exists in physical space. What else? Yeah, I don't know. Like you can set rotation. I don't know why I did that, honestly. But yeah, I'm gonna put this up on GitHub so you guys can play around with it. The same technique could also work for like hand tracking. You could like push particles around with your hand. Could be neat. Let me know what you think. Please hit the subscribe button if you enjoyed this. I'm also on GitHub as a, I don't know what to call myself, a sponsorable person. You can give me money on GitHub. That'll help me out. It'll motivate me to make more videos and keep me from freezing to death because I live in Canada now. Okay, guys, see you next time.